Welcome back to the deep dive. If you're listening, you probably already get the fundamentals of site reliability engineering. You know your SLOs, and, well, you've almost certainly been paged at 3 in the
He's
morning.
definitely been there.
But today, we're stepping past those fundamentals. We are going straight into the intense, high-stakes world of the war room.
Right.
We're talking about the critical moment-to-moment decisions that an incident commander or a lead SRE has to make, the people holding the line when millions of users and, honestly, millions in revenue are hanging in the balance.
That's a great way to put it. We're really moving into that intermediate and, I'd say, expert territory today. This deep dive is sort of custom-tailored for anyone who's prepping for that big leadership meeting or who's managing a major cloud-native deployment.
Or just wants to know what the pros do.
Exactly. We're synthesizing insights from, a lot of advanced SRE and incident management training materials, and we're focusing specifically on those complex, high-volume environments. Think things running on platforms like GKE.
Okay, so our mission for this deep dive, it kind of breaks down into 2 core challenges that I think really define modern SRE mastery. First, we have the crisis.
The firefight.
The firefight, yeah. Mastering the expert protocol for handling these complex failures while they're happening. The classic question. How do you change a tire on a moving bus?
And then the second part is the balance. This is more of the strategic, almost philosophical layer of SRE. It's where we stop chasing that idea of 100% perfection and start really mastering service-level objectives to, optimize business value.
Because our ultimate metric isn't perfect uptime, right? It's about finding the optimal risk profile for the business.
Precisely. We've distilled the best practices for these big cloud-native services where really the only true measure of success is how fast you can restore service. It's all about time to mitigate. So let's just jump straight in. Let's talk about a high-severity incident that requires just absolute discipline.
All right, let's do it. Part 1, the crisis. Protocol in the war room.
Okay, let's unpack this first scenario. It's a big one. Picture this. You're the incident commander.
Okay.
You're managing a hugely popular mobile game. I mean, millions of concurrent users. It's deployed across multiple Google Cloud regions using GKE. And then, bam, the alarms start screaming.
The worst sound in the world.
One entire region is completely down. Users there cannot connect. They're getting hard connection errors, complete timeouts. A huge chunk of your audience is just seeing nothing. Zero availability.
Yeah, that's a textbook high-severity incident. Pager goes off, heart rate spikes. A full regional failure is an immediate red alert. And for a lot of engineers, especially those maybe trained in a more traditional ops model, the instinct is to jump straight into diagnosis.
Right. Let me SSH into a broken node. Let me check CPU, check memory, start digging through terabytes of logs to find that one error message that started it all.
And that instinct, is logical, it makes sense. But based on the advanced SRE doctrine we've been reviewing, it's exactly the wrong first move. So why is that? Why do we have to push back against that very natural urge to diagnose the problem?
Because the SRE priority is always, and I mean always, time to mitigate. When an entire region fails, the primary concern is not the root cause. That can wait. It can wait 5, 10, 15 minutes.
The house is on fire. You don't start investigating the wiring.
You put the fire out. The immediate, non-negotiable mission is stopping the bleeding. You have to isolate the blast radius and restore service for those impacted users as fast as humanly possible. Debugging takes minutes, sometimes it can take hours, and every single minute you spend diagnosing is a minute. You're feeling millions of customers.
So the protocol, then, it mandates that the first action has to be this immediate, almost radical mitigation.
That's the word for it, radical. The first action must be to reroute the user traffic from the affected region to your other healthy regions, the ones that are still reporting full availability.
And what does that look like in practice?
Typically, it involves things like updating DNS records or manipulating your global load balancer configs, things like Google Cloud's global load balancing or GeoDNS, to just swiftly direct all new and existing connections away from that broken region.
Okay, wait a minute. I have to challenge that a little bit because that sounds really risky. I mean, if we immediately shunt, say, 20% of our global traffic onto the remaining 80% of our infrastructure, aren't we just risking a new kind of overload?
That is the essential trade-off.
Right. I mean, say the remaining healthy regions were already running hot, maybe at 65% capacity. You throw another 20% on top of that, you're pushing them to 85. Are you not just turning a regional failure into a global cascading meltdown?
And you've just highlighted the expertise required in that moment. Yes, you absolutely introduce increased load. You might even see higher latency in the healthy regions. but you are trading complete catastrophic unavailability for a marginally degraded but functional user experience. An end user who can connect, but experiences 100 milliseconds of extra latency is infinitely happier than a user who can't connect at all. You have to prioritize availability above all else in that initial triage phase.
So it's about containment. You isolate the blast radius, you stabilize the user experience for as many people as possible, and then the incident team can split its focus.
Exactly. Half the team can start diagnosing the original regional failure, satisfy that intellectual curiosity, while the other half is actively monitoring the increased load on the healthy regions and maybe scaling them up proactively if they need to.
So that's the coordinated approach. It's a huge lesson. Mitigation, especially rapid isolation and failover, it always comes before a deep root cause analysis when the blast radius is that large.
It's the speed of that first response that dictates whether the incident is just bad or truly catastrophic.
And this leads us to, I think, the next level of complexity. How do you deal with a failure when the service is already running under significant strain? This is moving from, mass triage to surgical precision.
Yeah, this next scenario is way more surgical. And it demands a really rigorous adherence to protocol. So let's imagine we have an ongoing incident. The service is running hot, say 70% overall capacity. It's peak load.
Okay.
And we spot a single critical node, or maybe a component within a microservice, that is returning consistent HTTP 5x errors for all requests hitting it. This one node is toxic. It's just poisoning user sessions.
So you need to get it out.
You need to get it out. You have to isolate it for investigation, but you have to do it while making sure that the entire fleet, which is already at 70% capacity, doesn't just collapse under the strain.
So the intuitive response, which I'm guessing is the dangerous one, would be to just tag that node as unhealthy, drain the traffic instantly, and just rick it out of the pool.
And that is precisely the counterintuitive rule we have to drill in. Do not simply drain traffic and remove the node immediately. I mean, think about it.
Yeah.
If you just yank out a node that was handling, say, 10% of the total cluster traffic,
You're just throwing that 10% onto the other nodes.
instantly, you redistribute that load onto the remaining 90%. And if your cluster was already at 70% capacity, that sudden influx could push several of those healthy nodes right over their saturation limits.
And then you get timeouts, higher latency.
And eventually, a cascade failure across the entire service. A local failure becomes a global incident because you acted too quickly.
Wow. So that sequence, taking a healthy node and tipping it into failure by overloading it, that's really the hallmark of a poor incident response.
It is, which is why we need a very precise, very controlled, 4-step protocol for managing this kind of high-stakes component failure.
Okay, so what's step one? What's the mandatory first step, even before you do anything technical?
Step 1. Communicate intent to the incident team immediately. This is all about synchronization. In the heat of the war room, you've got multiple people doing diagnostics, scaling, communications. The last thing you need is a rogue engineer taking unilateral action.
Right, because someone else might be doing something that conflicts with your action.
Exactly. Before a finger even moved toward that drain button, the incident commander, the comms lead, the other specialist, they all have to know exactly what resource you're targeting and what your intended action sequence is. If you miss that communication step, you risk someone scaling down the healthy fleet just as you're about to increase its load.
The comms channel is like the central nervous system of the incident.
Yeah.
Okay, so that's step one. Step two must address that risk of overload we talked about.
Right. Step 2, perform load analysis. This is the technical heart of the protocol. It is absolutely mandatory when you are operating above your standard buffer capacity. You have to analyze the capacity headroom of all the remaining healthy nodes.
So you're asking a specific question.
You're asking, can the rest of my fleet handle an instantaneous 10% increase in traffic, the traffic offloaded from the node I'm about to remove, without crossing critical saturation thresholds? Things like CPU connection count or memory pressure.
So if the load analysis comes back and says, hey, the remaining nodes are running at 80% CPU, and adding this poison node's traffic could push them to, say, 88 or 90%, if we don't have enough headroom, what then?
Then scaling has to happen before removal. If that capacity analysis shows you're in the danger zone, you need to provision and warm up new healthy nodes immediately. This takes time, I know, but waiting a few minutes is far less risky than crashing the entire service. You prioritize adding capacity over the speed of removal.
Okay, I have to push back on that again just to play devil's advocate. If we know this node is toxic and it's actively failing users right now. Why are we waiting for new capacity? Can't we at least start draining the traffic from the bad node while the new nodes are spinning up? Isn't parallelizing that process faster?
It sounds faster, but it carries a huge synchronization risk. If you start draining traffic from that toxic node before your new capacity is fully operational and taking traffic, that load immediately lands on your existing, already strained fleet.
You hit peak load before the cavalry arrives.
Exactly. The protocol mandates verification first, and that leads directly to step 3. Wait for new capacity. You only proceed when your new nodes are reporting fully healthy, they're warmed up, they're ready to absorb load, or when your existing nodes are verified as capable of handling that load shift without stress.
You have to verify that the new support structure is solid before you start weakening the existing one. It's a game of patience measured in seconds, but those seconds can prevent hours of outage.
Precisely. And only once those new resources are verified and integrated do we finally arrive at step 4. Drain traffic, then remove. You can now safely drain the traffic from the unhealthy node, making sure sessions are gracefully terminated or migrated, and then finally you remove the node from service so it can be investigated later.
And that controlled sequence ensures the transition is smooth, the traffic is absorbed by verified healthy capacity, which minimizes user impact and, most importantly, prevents that dreaded cascade failure.
It's the whole process.
That 4-step process is exactly why that analogy of changing a tire on a moving bus is mandated in this kind of advanced training, isn't it? The bus is going 70 miles an hour. You can't just rip the flat tire off.
You can't.
You have to ensure the load is shifted to the other wheels. That's your load analysis. You might have to add some new temporary support. That's your scaling. And only then do you take the bad wheel off. If you skip step 2, the whole vehicle could destabilize. That's the definition of systematic crisis management.
It really is. Okay, so the incident is resolved, the toxic node is gone, traffic's rerouted, users are back online. Now comes the really critical learning phase, the blameless postmortem.
Right. And this document isn't just administrative paperwork.
Oh, not at all. It is the fundamental tool for building resilience in your system and in your organization.
And the goal here, it sounds simple, but it is incredibly difficult to actually implement successfully. Prevent recurrence, not assign fault. This needs a very specific organizational and cultural commitment.
It does. Let's say the outage was caused by a new release that, exhausted memory resources. The postmortem must focus on identifying the contributing causes of the incident rather than the individual responsible for the cause.
So that means you have to abandon that impulse to run get blame and find the engineer who made the commit.
Yes. Or demanding disciplinary meetings to figure out who approved the change. That kind of behavior is just toxic. The SRE philosophy recognizes that in these high-complexity systems, failure is inevitable, and individuals are always operating within the constraints of the system, the tools and the processes that are provided to them.
So if an engineer makes a mistake, it's not a personal failing, it's a symptom of a systemic weakness.
Exactly. Maybe the testing coverage was poor, perhaps a monitoring threshold was set way too low, or the deployment process itself was just inherently risky. We have to focus on those systemic weaknesses.
And fix the process, not blame the person.
Precisely. So if the error was a memory leak in a new release, the action item shouldn't be train Bob not to do that again. It should be something like ensure that test cases that catch errors of this type are run successfully before new software releases.
Or maybe setting better saturation alerts on memory usage in your staging environment.
Right. You fix the process. Because if engineers fear punishment, they will hide errors. They'll delay reporting things, or they'll just refuse to participate honestly in the postmortem. And that guarantees future, and probably worse, failures.
So to make sure the postmortem is a high-value document and not just, a long report that no one reads, it has to be lean and focused. Of all the possible data points you could include, what are the 2 essential components that absolutely must be in there?
It's pretty straightforward. The postmortem must include an explanation of the root cause of the incident and, crucially, a list of action items to prevent a recurrence of the incident. Everything else, the endless logs, the chat transcripts, design docs, that's all supporting evidence. The core deliverable is understanding the why and defining the how to fix it.
Right. Without actionable items that are directly linked to the root cause, the whole exercise is just historical record keeping. It's not learning.
That's just a story.
So when do you always require a postmortem? We need some firm, non-negotiable triggers so that these critical learning opportunities are never skipped, no matter how quickly the service was restored.
There are two triggers that consistently demand a full postmortem. The first one is absolutely non-negotiable. If data is lost due to an incident. Data loss is often the highest cost failure you can have. It requires a full investigation to make sure you have protocols in place to prevent it from happening again, or at least minimize corruption.
Okay, that one's a given. What's the second trigger?
The second one, and this speaks volumes about modern SRE maturity, is when an external stakeholder asks for a postmortem.
Oh, that's fascinating. So the severity isn't just judged internally. It's about external trust signals.
Absolutely. A request from a major partner or a key customer or maybe even a regulatory body that signals that the impact went beyond the technical domain. It touched your reputation or critical business relationships. So even if the incident was internally simple, like say 15 minutes of degraded service, fulfilling that request with transparency is essential for maintaining trust.
Transparency, even when you fail, is a competitive advantage.
It really is.
Okay, so let's talk about those action items. We've all seen postmortems where the to-do list is 30 items long, and 6 months later, 25 of them are still marked pending. How do you inject accountability without assigning blame and make sure these things actually get done?
You combat diffused responsibility. The best practice is always align to sign one owner for each action item and any necessary collaborators. One single owner is held accountable for driving that specific fix to completion.
Not multiple owners.
You have to avoid multiple owners, because when 3 people own something, nobody owns it. And conversely, assigning an item to a vague group like the SRE team or platform engineering just ensures it's going to drift into the abyss. Single ownership brings clarity, priority, and execution. The owner is responsible for completion, not necessarily for doing all the work they can delegate or collaborate, but they are the singular driver.
Okay, that's the tactical side. Finally, we need to address the cultural implementation. Postmortems can quickly get a reputation for being bureaucratic toil. How do you make sure this demanding process is actually welcomed and successful?
First, you need visible buy-in from the top. You have to encourage senior leadership to acknowledge and participate in postmortems. When the CTO or a VP of engineering or a product lead is present, reading the findings, engaging with the proposed solutions, praising the team for the speed of mitigation, it elevates the whole practice. It signals that organizational learning is a business imperative, not just an engineering chore.
If leadership treats it like a serious learning session, the teams will too. Makes sense. What's the second cultural pillar?
You have to ensure that writing effective postmortems is a rewarded and celebrated practice. This means explicitly recognizing engineers who write detailed, insightful, and actionable reports. This could be through performance reviews, internal awards, or even just allocating resources based on the quality of their contribution to the organization's resilience.
So if the work is seen as punitive, it fails. But if it's seen as one of the highest forms of contributing to future stability and velocity, people will actually invest the intellectual effort.
Exactly. And that culture needs to ensure the postmortem covers what caused the incident, how it was resolved, and how to prevent it, all without, naming customer information or identifying internal systems in a way that might risk security.
Okay, that provides a really robust foundation for handling the crisis. Now let's transition from that immediate firefight to the long-term strategy. Because once you have the incident protocol locked down, the real expert work begins, balancing reliability with business velocity. And that means mastering the error budget.
This is where SRE gets really interesting.
Part 2, the balance, mastering SLOs and error budget strategy.
Right, and defining the right service level indicator, the SLI, that's the foundational step in this whole strategic balancing act. If you measure the wrong thing, you will optimize for the wrong outcome. And you could sink a ton of resources into metrics that don't actually reflect user satisfaction.
Let's analyze a classic problem here, scenario.
Yeah.
You have a data-intensive reporting feature. Users access it. It's failing a lot, returning HTTP 500 errors.
Okay.
When you investigate, you notice these failures correlate perfectly with a huge spike in the application's internal report generation queue size. That queue is saturated because the backend is experiencing high I/O wait times on its storage.
A very common pattern in complex cloud-native architectures, where different components rely on shared resources. So the failure is obviously related to saturation and latency. The pipe is full, the system is slow, requests are timing out, and that's leading to 500s.
So here's the challenge. We need an availability SLI for this feature. Which metric defines availability best? Is it the internal plumbing, like I/O wait time, or the queue size? Or is it the resulting user outcome?
And the SRE doctrine is crystal clear on this because it focuses on the user's perspective. The correct availability SLI is defined as the proportion of report generation requests that result in a successful response.
And this really emphasizes that critical difference between user-centric metrics and internal metrics.
It does. The user who's trying to pull a report, they don't care about the internal state of your I/O subsystem. They don't care that the queue depth hit 5,000 requests.
They care about one thing.
Did the report work? Did I get a successful response? That's it.
So if we used something like queue size or I/O wait time as our main availability SLI, we would create a kind of perverse incentive. We could optimize the system to keep the queue small, but if the successful requests are still returning, say, corrupted or incomplete data, which is still a failure from the user's perspective, we technically met our internal metric, but we failed the customer.
Exactly. Queue size is an excellent indicator of saturation. I/O wait time is a great measure of latency or back-end performance. But neither of those accurately reflect availability, which has to be defined by whether the service delivers its promised outcome. When you set an SLO around a 99% success rate, you're setting a contractual expectation based on the user's tangible outcome. This forces SREs to fix the user-facing failure, no matter how complex the underlying saturation is.
Speaking of outcomes, we have to transition from just reactive measurement to proactive capacity planning, especially before a massive known event like a big holiday sales push or global marketing campaign. What are the two non-negotiable prep actions SREs have to take for peak load planning?
First, SREs must always manage it. Review increased capacity requirements and plan for the required quota management. In these highly elastic cloud environments, capacity isn't unlimited, it's allocated via quotas.
Right.
You have to forecast the expected load spike and make sure you have requested and been granted the necessary quotas for CPU, memory, IP addresses, I/O limits, all of it, in advance. Hitting a hard quota limit during peak load is a catastrophic failure of preparation that no amount of reactive scaling can fix.
That's a failure that happens weeks before the event even starts. Okay, what's the second critical piece of prep work?
You must ensure that relevant system metrics are being captured with cloud monitoring and create alerts at levels of interest. This means running extensive load tests or maybe even chaos engineering experiments to profile the application's performance curves for scaling. You need to know exactly when latency starts to degrade, how fast you need to scale, and you have to ensure those leading indicators like queue depth, connection pooling, specific latency percentiles are properly instrumented and are alerting you before the service starts returning 500s to the customer.
This takes us right into the expert level of error budget management. We're moving beyond just measuring the SLO and starting to actively manage the risk in real time. The goal is to detect that budget consumption early enough to protect customers and, decisively guide product release policies.
Yeah, a foundational mistake a lot of new SRE teams make is alerting only when the error budget is near zero or completely exhausted. By the time you get that budget exhausted alert, the damage is already done. The incident has severely impacted users, and a painful immediate launch freeze is pretty much mandatory.
That's too late to intervene gracefully.
It's way too late. The advanced SRE practice we're looking at is entirely different. It focuses on the velocity of consumption, not just the absolute remaining budget. The correct method is to create a SLO. Create an alert policy on select slow burn rate.
The burn rate.
The burn rate. Alerting on the burn rate tells you if you're spending your budget too quickly relative to your measurement window. Let's use the gas tank analogy. If your SLO allows for 1% downtime per month, that's your tank of fuel. Alerting on budget exhaustion is like getting an alert when the tank is empty. You're already stranded on the highway. Alerting on a high burn rate is like getting an alert because your gas gauge is visibly dropping way faster than expected, maybe because you have a fuel leak. You still have time to pull over, identify the leak, and prevent being stranded.
That is a crucial insight. A high burn rate doesn't necessarily mean a huge total outage yet, but it indicates a minor, sustained issue or sudden, severe spike that if you don't check it will inevitably lead to that launch freeze.
Right. If you're burning 50% of your monthly budget in the first 3 days, the burn rate alert forces an immediate mitigation effort and a very serious conversation with the product team.
It creates the necessary urgency.
It does. You calculate the error budget depletion relative to the expected depletion over the remaining time period. If you detect you're consuming your budget at, say, 10 times the normal rate, you only have 1/10 of the time left before that launch freeze kicks in. This gives product managers and engineering leads a quantifiable, objective lever to prioritize stability work over new feature releases.
And this proactive approach to alerting, it ties directly back to one of the most critical cultural goals of SRE, reducing staff burnout. If engineers are constantly getting paged for things that don't matter, they stop responding seriously to the things that do.
Absolutely. In the context of reducing burnout, the established SRE practice is to eliminate alerts that are not actionable. If you have systems that are designed to automatically restart or self-heal or reroute traffic within 60 seconds and restore service without any human intervention,
Don't page an engineer.
do not page an engineer for that event. That is just toil disguised as vigilance. It wastes human capital and it leads directly to alert fatigue, which makes the engineer ignore the truly severe incident when it finally arrives.
The failure is captured by the SLO, which tracks that little blip of unavailability. But the system's self-healing nature means a human doesn't need to wake up. You focus human attention only on the incidents that require immediate human decision-making.
Like the capacity analysis we talked about in the traffic draining protocol.
Exactly.
Okay, so this next part is, I think, the most strategically profound and maybe the most culturally difficult concept for engineers to accept, and that's the metric of perfect failure.
Let's set the scene for this expert-level decision. You have a service that is just a runaway success. It's consistently meeting its SLO. In fact, over the last 6 months, it has never consumed more than 5% of its error budget in any given time window.
Looks great on a dashboard.
It looks fantastic. And business stakeholders confirm the SLO is set appropriately. Customers are happy with 3 nines of availability. They don't need more.
So this looks like a huge success. But to a lead SRE or an incident commander, it should signal inefficiency and waste. We have to internalize that 100% reliability is the wrong goal.
See that again?
100% reliability is the wrong goal. If you are reliably underspending your error budget, if you only use 5% of the 1% allowed downtime, you are investing significantly more engineering time, expensive infrastructure, and operational complexity for reliability that the customer isn't paying for and the business doesn't strictly need.
The engineer's pride is in achieving those extra nines, but the business consequence is actually wasted opportunity.
Exactly. You are sacrificing development velocity and resource optimization in the pursuit of a perfection that generates zero additional revenue. The difference between 99.9% and 99.999% availability often costs exponentially more to achieve and maintain, but it delivers zero tangible business gain if the customer doesn't expect it.
So this requires a strategic course correction. You have to leverage that unused budget. What are the 2 best strategic responses when your reliability is demonstrably too high?
The first response is to give that budget back to the product team in the form of speed. You should increase the service's deployment velocity or risk.
Take more risks.
Yes, you use that surplus budget as permission to ship faster. This might mean shortening the testing cycle for non-critical features, or integrating more aggressive canary deployments, or even intentionally running small, controlled chaos engineering experiments that might cause transient, minor failures. You're telling the product team, you have 95% of your failure budget left, go spend it on speed and innovation.
That reframes the entire idea of an error budget. It goes from being a compliance hurdle to being an innovation accelerator. Okay, what's the second strategic response?
You shift engineering time to other services that need more reliability. If Service A is overperforming, those highly specialized SRE hours, which are a finite and very expensive resource, are better spent stabilizing Service B, which might be routinely exceeding its error budget or suffering from high toil or burdened by legacy tech debt. This is about strategic portfolio management. You have to ensure SRE effort is allocated where the ROI on stability is highest.
This idea of intentionally introducing risk or reducing your reliability investment must be incredibly challenging for the engineering mindset, which is, culturally conditioned to prevent all failure. How do you get past that psychological barrier?
It requires leadership to constantly reinforce the economic and cultural mandate. The engineer has to understand that the cost of their time is extremely high. Every hour they spend hardening Service A from 5 nines to 6 nines is an hour not spent on an urgent, revenue-generating feature, or not spent stabilizing a service that is actively failing customers. By over-delivering on reliability, the SRE team is inadvertently starving other critical business functions of needed resources.
So the discussion shifts. It goes from, is it possible to achieve 100%, to what is the opportunity cost of chasing 100%?
Exactly.
So let's say the application is consistently using only 5% of its budget. Aside from increasing risk or shifting resources, what are some follow-up options the team should consider to better align the SLO with reality?
Well, first, the team should look inward. and maybe tighten the SLO to match the application's observed reliability. If you're reliably delivering 5 nines, but you're only promising 3, tighten that SLO. This sets more realistic internal target, it increases accountability, and it potentially formalizes the resources you're already using to achieve that.
And a second option.
Second, they should implement and measure additional service level indicators, SLIs, for the application.
Why add more SLIs if the system is running so smoothly?
Because if the system is running that perfectly based on a single metric, like general availability, it often means that single SLI isn't capturing all the dimensions of the user experience or potential technical debt. You might be masking poor performance in specific areas, you might need to add very strict latency SLIs for critical payment paths, or throughput SLIs for heavy back-end processes to find where the remaining inefficiency or latent risk really lies.
So you're essentially looking for intelligent ways to spend that surplus engineering time, either by finding new ways to measure user quality or by intentionally shifting focus.
Right. This philosophical framework ensures that every SRE decision is tethered to business value.
Which brings us to our last section, cost versus value.
This is where SRE truly becomes a business function. Reliability decisions cannot be driven by technical capability alone. They must be tied back to a clear return on investment. We have to be able to prove that chasing those additional nines is worth the money.
Okay, let's use the explicit quantitative example from the training material, and let's walk through this step by step to make it super clear. An organization is considering a proposal to increase availability from 99.9% 3 nines to 99.99% 4 nines.
Okay.
This upgrade requires a dedicated investment of $2,000. That covers new redundancy, extra tooling licenses, the engineering time, all of it. The application's current annual revenue is $1 million. The question is this reliability improvement fiscally justified for a single year?
Right. So we start by quantifying the difference in service level. We have to calculate the acceptable annual downtime for both of those targets. First, at 99.9% availability, the system is allowed to be unavailable for 0.1% of the year.
And what's that in real time?
In a standard year of 8,760 hours, 0.1% of that is 8 hours and 46 minutes of annual downtime.
Okay, so that's the revenue risk at the current level. Now, for the higher target.
At 99.99% availability, the system is allowed 0.01% downtime. And 0.01% of 8,760 hours is approximately 52 minutes and 36 seconds of annual downtime.
So the difference between 3 nines and 4 nines is roughly 7 hours and 53 minutes of potential revenue loss that you're avoiding. You're protecting those almost 8 hours of potential failure time.
Exactly. That, let's call it 8 hours, represents the potential revenue we save by achieving that higher availability goal. Now we have to quantify the value of avoiding that downtime.
The application generates $1 million a year. How do we convert that into an hourly rate?
We just divide the annual revenue, $1 million, by the total hours in a year, 8,760. And this calculation shows that the service generates revenue at a rate of approximately $114 per hour. That's the rate at which revenue is lost during downtime.
So we take the 8 hours of potential downtime that we're protecting with this upgrade, and we multiply it by the revenue rate of $114 an hour.
And the calculation provided in the source material states that the value of that improved availability is calculated to be $900. It's the 8 hours times $114 an hour, rounding a bit for simplicity. This means that by moving from 3 nines to 4 nines, you are protecting a maximum of $900 worth of revenue that you were previously risking.
And the cost of protecting that $900 is $2,000.
So the conclusion is pretty undeniable. The investment of $2,000 is greater than the $900 value derived from the reliability increase. Therefore, the increase in availability is not worth the investment. The company would be better off accepting the risk of those 8 hours of downtime, absorbing the potential $900 loss, and redirecting that $2,000 investment toward future development, or stabilizing a service with a more positive ROI.
And that is the hard truth that professional SREs have to deliver to product management sometimes. It proves that the lead SRE's role is often about convincing the business not to spend money on reliability they don't strictly need, because chasing that next 9 is a path of diminishing returns.
That $1,100 difference, the overspend, could have funded a new feature or reduced toil somewhere else in the system. It forces SREs to align their technical efforts with the P&L statement.
So if you're consistently delivering 4 nines, but the business only requires 3, you've effectively overspent by $1,100. That's capital that could have been reinvested in increasing deployment velocity or reducing team burnout.
And we also touched on the other side of that coin. When the error budget is exceeded, the product team has to negotiate for a launch freeze or tolerate a slightly worse user experience. This enforces the discipline that the budget is a hard limit on risk, protecting both the customer and the business.
And if that budget is exceeded and the team needs to get back on track urgently to avoid a long launch freeze, what's one key action that helps them reduce the administrative drain and get back to valuable engineering work?
That takes us back to that intermediate level of essential maintenance. You have to identify, measure, and eliminate toil by automating repetitive tasks. Toil, that manual, repetitive, automatable work, it consumes engineering resources that should be focused on the high-value tasks, like increasing feature velocity or hardening systems based on postmortem findings. If you eliminate toil, you free up the engineering cycles you need to address the root causes and get the service back on budget. Toil is the silent killer of both your budget and your velocity.
Excellent point. Okay, let's just summarize the journey we've taken today. We started in that intense pressure cooker of incident command, where the first move is always mitigation rerouting traffic away from a failing region immediately to control the blast radius.
Right, prioritizing availability above everything else. Then we learned that precise, controlled, four-step protocol for removing a single failing node without crashing the whole service, emphasizing that critical load and capacity analysis that has to happen first.
And then we transition to the strategic layer, understanding that a strong SRE culture relies on rigorous, blameless postmortems, driven by visible senior leadership, focused relentlessly on systemic root causes, and assigning actionable, individually owned items to make sure things get done.
Finally, we saw how true SRE mastery involves using the error budget as an objective tool for driving velocity and managing risk. We learned why monitoring the burn rate gives you that proactive power to intervene, and critically, how to identify and avoid the trap of too much reliability by taking calculated strategic risks or shifting resources to where they're needed most. The budget isn't a quota to avoid, it's permission to fail intelligently.
And that brings us to the core philosophy we covered in part 2. If you take away one single concept from this deep dive, especially if you're working at that incident commander or lead SRE level, let it be this. The ultimate SRE goal is not 100% reliability. The goal is to be exactly as reliable as the business needs and not one bit more.
That's it.
Too much reliability isn't just technically impressive, it is a wasted resource, whether that's engineering time, compute resources, or slower deployment velocity. This is the concept that expert SREs have to internalize to really optimize engineering effort and maximize business value.
Yeah, when you truly move into the expert domain of SRE, you realize you're managing economic trade-offs, not just pursuing technological perfection. That nonlinear cost curve of reliability means that every minute of planned downtime you prevent costs exponentially more than the last one until you cross that point of diminishing returns, just like our $900 value calculation clearly showed.
And this leaves us with a final provocative thought, building directly on that economic argument. We saw that if high availability is proven to be unprofitable, if the cost of chasing that next 9 significantly outweighs the potential revenue it protects, what obligation does the SRE team have to the business to intentionally introduce a small, controlled amount of risk or acceptable failure into the system?
It's a tricky question.
Not to hurt customers, but to actively reduce operating costs and reallocate those expensive engineering hours back to value-driving features.
It's the ultimate question of optimization, isn't it? Is intentional, managed under delivery of reliability when the customer's stated needs are already met and the ROI is negative, is that the highest form of business alignment? Something to definitely mull over as you review your next SLO report and capacity plan.
Thank you for joining us on the deep dive. We'll catch you next time.